Good day, all functions. Today, let's talk about the mean of discrete random variable.
As a review, a list consisting of all possible values of a discrete random variable with its corresponding probability is called discrete probability distribution. Now let's have our example. Now let us consider our discrete probability distribution in tossing two coins at once, in which the random variable x is the number of tails that may occur. Alright, now we know that when we toss two coins at once, there can only be four possible outcomes, and these outcomes are heads and heads, heads and tails, tails and heads, and tails and tails. Now that we have already identified our possible outcomes when we toss two coins at once, now it's easier for us to determine the value of our random variable x. Now, let us remember that the random variable x here is defined as a number of tails that may occur. Looking at our sample space, we can already identify that the value of our random variable x are 0, 1, and 2. 0 when our outcome is head and head. 1 when our outcomes are head and tail or tail and heads. And 2 if our outcome is tails and tails. Now constructing our discrete probability distribution, we have for the possible values of x, we have 0, 1, and 2. Now the probability that no tail will occur is 1/4. The probability that one tail will occur is 1/2 or 2/4. And the probability that two tails will occur is 1/4 also. Now that we are done with the discrete probability distribution, we are asked with the question, what is the average number of tails that could appear? To solve for the average number of tails that could appear, then we need to compute for the mean of the discrete random variable, which is also called as the expected value. So the expected value is the weighted average of all the values of the random variable x would assume in the long run. The mean or expected value of a random variable is computed using the formula. The expected value of the random variable x is equal to the summation of x times the probability of x, where big letter X is the discrete random variable and the small letter x is the value of the discrete random variable, and p of x is the probability of the value of the discrete random variable. Alright, now solving for the average number of tails that could appear, let's have our solutions. Now the expected value of the random variable x is given by the summation of x times the probability of x. Now, we know that summation pertains to the total, meaning to say we will add. Alright, so here let's start first with first value of x, which is 0. So we have 0 times, the corresponding probability of 0, which is 1/4. plus K1 and its corresponding probability, which is 1/2, plus 2 and its corresponding probability, which is 1/4. 0 times 1/4 is 0, so we have 0, plus 1 times 1/2 is 1/2, plus 2 times 1/4 is 2/4 or 1/2. Adding 0 plus 0, 1/2, and 1/2, we have 1. Meaning to say that the average number of tails that could appear is 1. Alright? Now remember that the mean is the value that we expect the long-run average to approach, and it is not the value of the random variable x that we expect to observe.
Now let's go to example 2. Consider rolling a die. What is the average number of spots that would appear? Let the random variable y be the number of dots that could appear in rolling a die. Alright, so based on the problem, what is asked is the average number of spots that would appear. So we know that to solve this problem, we have to solve for the mean of the random variable y. But before we can solve for the mean, we need to construct the discrete probability distribution of our random variable. So constructing the discrete probability distribution of the random variable y, we have y here and the p of y. Now, we know that when we roll a die, there are only 6 possible outcomes. And the 6 possible outcomes are 1, 2, 3, 4, 5, and 6. Okay? And the probability of getting 1 spot is 1 over 6. Getting 2 is also 1 over 6. Getting 3 is 1 over 6. Getting 4 is also 1 over 6. Getting 5 is also 1 over 6. And getting 6 is also 1 over 6. Alright? Now that we are done with the probability distribution, then we can solve for the mean. Now the formula in finding the mean of the random variable is given by the summation of the product of the y and its corresponding probability. Okay, so we have here the expected value of y is equal to the summation of y times the probability of y. That is, let's start first with 1. So 1 times 1 over 6 plus 2 times 1 over 6 plus 3 times 1 over 6 plus 4 times 1 over 6 plus 5 times 1 over 6 plus 6 times 1 over 6. Now using your calculator, we will get an answer of 3.5. So meaning to say that the average number of spots that would appear when we roll a die in the long run is 3.5. Although the die will never show a number of 3.5, this implies that rolling the die many times, the theoretical mean is 3.5. Now let's have example 3. An insurance company sells life insurance of 500,000 for a premium or payment of 10,400 per year. Now, actuarial tables show that the probability of normal death in the year following the purchase of this policy is 0.1%. What is the expected gain for this life insurance policy? So for this problem, we are asked to solve for the expected gain or the expected value of the insurance policy. Now, before we can solve for the expected value, we need to construct first the probability distribution of this problem. So constructing the probability distribution, we have, outcomes and the probability. Now we let our outcomes be the x, and the probability is the probability of x, or the p of x. Okay? Now at the end of the year, there can only be two outcomes for this problem. It is either the customer will live, or the customer will have a natural death at the end of the year. Okay? And when the customer lives at the end of the year, the insurance company will actually gain 10,400. But when the customer will die a natural death at the end of the year, the company will actually lose 489,600. And since the company will lose 489,600, then we will reflect it here in our table as negative. And why is it not 500,000 pesos? Because remember that the customer will pay 10,400 pesos. So we will subtract 10,400 from 500,000. That is why the company will only lose negative 489,600 in the event that the customer will die a natural death at the end of the year. Okay? So now that we have identified the outcomes for this problem, then let's go to the probability of each outcome. Now, based on the problem, the probability of normal death in the year following the purchase of this policy is 0.1%. Okay? And 0.1% in decimal is 0.001. So the probability that the customer will die in natural death at the end of the year is 0.001. And to find the probability that the customer will live at the end of the year is 1 minus 0.001, and that is 0.999. Right? So we are done now with our probability distribution. Okay? So now we are set to solve for the expected gain of this insurance policy. So for the solutions, we start with the formula, and that is the expected value of x is equal to the summation of the value of the random variable x times its corresponding probability. So that is, let's start first with 10,400 times 0.999 plus, negative 489,600 times 0.001, multiplying 10,400 times 0.999 is equal to 10,000
389.6, okay, plus okay, 489,600 times 0.001 is equal to negative 489.6. Now, subtracting 489.6 from 10,389.6, we have 9,900. Meaning to say, the expected gain of the insurance policy is 9,900. It is a gain because our final answer here is a positive. So the company has an expected gain of 9,900 for every sold insurance policy. Now take note that if the insurance company were to sell a very large number of 500,000 insurance policies to many people with the long run average profit per insurance policy of 9,900 pesos, then the company would be expected to make a total profit of n times 9,900. Let's have example 4. The probabilities that a surgeon operates on 3, 4, 5, 6, or 7 patients in any day are 0.15, 0.10, 0.20, 0.25, and 0.30 respectively, and find the average number of patients that the surgeon operates on a day. So we are asked to find the average number of patients that the surgeon operates on a day. So we are going to find the mean of our discrete probability distribution. So we let x be the number of a surgeon that operates on a day, and the p of x is the probability of x. So based on the problem, the surgeon operates on 3, 4, 5, 6, or 7 patients in any day. So that those are our values of the random variable x. So we have here 3, 4, 5, 6, and 7. And their corresponding probabilities are 0.15, 0.10, 0.20, 0.25, and 0.30. Okay, so now that we are done with the probability distribution, we can proceed now to our solutions. So solving for the mean of the random variable x, we start with the formula. So that is expected value of x is equal to the summation of x times the p of x, and that is 3 times 0.15 plus 4 times 0.10 plus 5 times 0.20 plus 6 times 0.25 plus 7 times 0.30. Now using your calculators, we will get a sum of 5.45. So meaning to say the average number of patients that the surgeon operates on a day is 5.45. Alright? Next, example 5. The officers of a barangay are planning to give away 160 tickets to be raffled for a charity event. Now the ticket is for free. Now one ticket will win 3,000 pesos and the other tickets will win nothing. Now you are a resident of the barangay and you got
one ticket. Now, what is the expected value of your gain? Okay, so in this problem, there can only be two possible outcomes. It's either you lose or you win. So when you win, you get 3,000 pesos. But if you lose, since the ticket is for free, then you lose nothing. So when you lose, then you lose nothing. Okay, so that would be 0. Okay, now there are 160 tickets that were given away for the raffle, and you got one ticket. So your probability of winning is 1 over 160 because you only have one ticket and there are 160 tickets that were given away. And the probability of losing is, of course, 1 minus 1 over 160, and that is 159 over 160. Okay, so now you are done with your probability distribution. So we can proceed now to solving for the expected value. So the expected value of x is equal to the summation of x times the probability of x. That is, when you win, you have 3,000 pesos times 1 over 160 plus, 0 times 159 over 160. Okay, using your calculators, you have 18 pesos or 18.75 as your expected value. And since your expected value is 18 pesos and 75 centavos and it's positive, then meaning to say it is an expected gain. Okay, it is an expected gain. Now, what if the ticket is not for free? Let's have the following example. The officers of a barangay are planning to sell 160 tickets still to be raffled for a charity event. Now the ticket is worth 50 pesos. In the previous example, the ticket is for free. But in this, the ticket now is worth 50 pesos. Now one ticket will win 3,000 pesos and the other tickets will win nothing. Now, if you are a resident of the barangay and you got one ticket, what is the expected value? Is it going to be an expected gain or an expected loss? So again, for this problem, there are only two possible outcomes. It's either you win or you lose. Now, if you win, okay, you get 3,000 pesos. But remember that you paid 50 pesos for the ticket. So meaning to say, we will subtract 50 pesos from 3,000. So your net gains when you win is equal to 3,000 minus 50, and that is 2,950 pesos. Okay? And when you lose, of course, you lose 50 pesos. So that is reflected as negative 50. Now, you only have one ticket and there are 160 tickets to be raffled for the charity event. So you have here the probability of winning is 1 over 160 and the probability of losing is 159 over 160. Okay, solving for the expected value, we have the summation of x times the probability of x. And that is equal to, okay, 2,950 times 1 over 160 plus, okay, here you have already negative 50, so you have negative 50 times the probability of losing is 159 over 160. Now use your calculators. Okay, we will get a sum of negative 31.25. So since it's negative, meaning to say it is an expected loss. So the expected loss of the game on your part as a resident of a barangay who spent 50 pesos for the ticket is 31 pesos and 25 centavos. So since it is an expected loss, are you still going to participate in the raffle or not? And it's for you to decide. So that's all for today. I hope everything is clear and see you in our next video.